Hey, welcome to today's lesson. We are actually wrapping up our unit on naming. We're going to do 7.4 and learn how to name acids. So without further ado, let's take a look at those notes. So today we are naming acids. Acids are this whole compound of, or whole group of compounds. And let's start by kind of giving them a general definition. So the Arrhenius theory of acids states that acids release H plus when they're dissolved in water. So first of all, yes, Arrhenius theory is just one of three different theories of acids. We'll discuss the other two in a little bit more detail later in the year around spring break time. We have a whole unit on just acids and bases. But for right now, we're going to focus on the Arrhenius theory, which again is telling us two things here. Acids release H plus when they're dissolved in water. Just kind of draw a little diagram here to visualize this. Here is an acid, HA. So if you're going to release H plus, you have to start with H. We're going to use A, kind of like the variable X in math. So A is a variable for us, and it can represent any anion that we have, and we have quite a few of them. We'll take a look at some of them in just a minute here. But the idea is when you take this acid and you put it into water, when you take this compound, put it into water, it dissolves. And what that looks like is that these H pluses come off the A negative. Your positive and negative parts break apart. That's what dissolving is. If you've ever taken table salt, NaCl, and put it into water and all of a sudden you can't see it, it's dissolved. The reason why you can't see it is that crystal, that NaCl crystal with a whole bunch of repeating Na and Cl's, they dissolve, they pull apart until you have only Na plus and Cl negative floating around in water kind of by themselves. And they're too small to see individual tiny little atoms, or in this case, ions. And so that's what dissolving is. An acid specifically dissolves and gives up an H plus when it's in water. So again, this Arrhenius theory is telling us two things. And these two things are really useful when you're identifying acids. First, when you're working with an acid, it always has to have an H as the cation. Again, if you remember our ionic compounds, we have a cation first and an anion second. Well, in the case of an acid, H is always our cation. And it always has to be dissolved in water. The way that we show that is by writing AQ after it, aqueous. AQ stands for aqueous, which means that substance is dissolved in water. So acids should be really easy to recognize. They're always going to start with an H, and they always have to have aqueous, AQ, after them. Couple of rules when we're naming acids. It all depends on the ending of the anion. The ending is ide, I-D-E. You change it to hydro, list your anion, put the ending ic. So we erase the IDE and put ic, finish it off by calling it acid. Got some little gimmicks that kind of help. At least I think they help. So you're more than welcome. These have saved my life many times. The first one is my ride has hydraulics. And so what we see here, ride ends in IDE. So we see IDE, add hydro and ic. My ride has hydraulics. We're like talking about my car, hydraulic lifts are like what makes it kind of bounce up and down. Back in the 90s, at least, they were pretty popular to have your car really raise and then lower and do tricks and all sorts of cool things. But doesn't really matter if we use them too much. We just got to remember my ride has hydraulics. When the ending is IDE, we add hydro to the front and ic to the end. Another common ending, 8. So if the ending is 8, change the ending to ic, and then put the word acid. So 8 becomes ic. Now you notice it was ic up here as well. The difference is when it ends in IDE, we put hydro in front. Most of our IDEs are going to come from the front of the periodic table. Just a regular old single anion, nitride, oxide, fluoride, sulfide, chloride. Those all end in IDE, so we're going to follow that rule. The 8 ending are polyatomic ions. Remember, most of these guys are also negatively charged, so they're also anions. So they, sure enough, can be part of an acid. Just put an H on front, and you've got yourself an acid. Dissolve it in water, and you've got yourself an acid. So when these guys end in 8, which a lot of them do, when those guys end in 8, we change the ending to ic. Again, no hydro in front. The gimmick there is I ate something icky. So I ate something icky. The ending's 8, change it to ic. And then finally, the third ending you might have when working with an anion. If the ending is "ite," and again, you're going to see that on a lot of our polyatomic ions, they end in either "ate" or "ite." So there's "nite," there's "nite." Quite a few "ites." Again, we don't put anything on the front. The only time we put something on the front is when it ends in IDE. If it just ends in ITE, we're going to end it with OUS, OS, acid. And the saying there, Sprite is delicious. I don't know if you agree with it or not. To be honest with you, I don't even find Sprite to be that good, but the saying works. Sprite is delicious. If it ends in ITE, we put OUS. All right, let's take a look at some examples. Just one page here, there we go. So we'll start off. Going formula to name. So if you're given the formula HCl, AQ, Again, you can tell pretty easily it's an acid. It starts with H, ends in AQ, dead giveaway working with an acid. Well, if I were going to name this regularly, I would call this hydrogen chloride. We see the IDE there. We think back to the other side. My ride has hydraulic, so IDE becomes hydro, anionic. So to name this as an acid, we would say, we'll start off with our hydro, then we put the anion part, chlor, but we change the ending to IC. So hydrochloric acid. There's our HCl, hydrochloric acid. There's our polyatomic ion, CN. We know we're working with a polyatomic ion, so we've got more than two elements, so at least one polyatomic ion. It's almost always the back couple of letters. So take a look for CN, there it is, cyanide. If I were to name this regularly, I'd call it hydrogen cyanide. And there's that IDE ending. So we change it to hydrocyanic acid. Hydrocyanic acid. And ide becomes hydro. There's the anionic acid. It starts with an H, has an AQ at the end, so it's dissolved in water. More than two elements. We've got H, we've got Cl, and we've got O. So that means we're working with a polyatomic ion. Let's figure out which one. ClO. We've got four of them, so ClO4. There it is. Perchlorate. And if I were to name this regularly, following the rules we have, I'd call it hydrogen perchlorate. ATE. What's our rule for ATE? When something ends in ATE, I ate something icky. ATE becomes IC. So again, no hydro this time. Hydro only goes with IDE. This time, we just name the anion, and we change the ending to ic. So 8 becomes ic, perchloric acid. HNO3. Again, we're working with a polyatomic ion. We've got more than two elements. So we're looking for NO3. There it is, nitrate. Once again, if I were just to name this regularly, I would call it hydrogen nitrate. ATE. I ate something icky. Again, we're not going to put hydro. We're just going to put the anion, so nitric, change the 8 to ic, and call it acid. Be sure to watch out and don't put hydro. That's only if it ends in IDE. There is actually a hydronitric acid, and it's completely different from HNO3. It's actually H3N. So big difference between hydronitric acid and nitric acid. So I ate something icky, we just change 8 to ic. No hydro. H2SO3, again, 3 letters. So we've got at least one polyatomic ion here. Looking for SO3. There it is. Sulfite with an ITE. So we can see an example naming with that ITE, hydrogen sulfite. Again, ITE. This one's kind of weird. When we went to sulfite, or sometimes we go to sulfate, we drop the UR. So think of like sulfur. So sulfide, sulfate, sulfite drops the UR. For whatever reason, we bring the UR back when we name it as an acid. So sulfurous acid. For me, it's an ear thing. I hear it. I know that sulfus acid doesn't sound correct. I don't know if you hear that or not. I don't know if you're hearing that and thinking, sulfus. It doesn't come off the tip of your tongue. Maybe it only does for me because I've heard it so often before. But you want to remember to put that UR back in there. Sulfurous acid. Ite becomes OUS. Sprite is delicious. And we'll do one more, HClO, and it starts with an H. It ends in aqueous. We need to find ClO. There should be. Hypochlorite, and there's that ITE. So if we were to name this regularly, we'd call it hydrogen hypochlorite. Again, it ends in ITE. So what we're going to do is we're going to change the ending to OUS. We're not going to do anything with hydrogen. Okay, we only did that up here when it ended in ide. Now we do have to keep hypo on there though. That's a part of the anion. But you know, there's not very many O's there. Hypo, below, under. So hypochlorous acid. There's our anion, hypochlor, OUS, OS, because it was ite. So hypochlorous acid. Take a couple examples of name to formula. So go on the other way. Again, recognizing an acid should be really easy for you. Because it's going to end in the word acid. So recognizing you're working with an acid should be pretty easy. And now we just got to work backwards. Hydrosulfuric, my ride has hydraulics. So we're looking for sulfide. Sulfide is off the front of the periodic table. It's the anion of sulfur. Sulfide has a -2 charge. So I'll go ahead and I'll write that. That would be sulfide, which would lead us to go to hydrosulfuric. So sulfide. The other side of it, we always have to have H. It's an acid. Acids always start with H. So H plus 1, S -2. We need to balance out the charges here. If you want to cross over, that's fine. If you just want to prefer to do the math, it's going to take 2 of my positive 1s to cancel out my 1 -2. So this one ends up being H2S. Make sure you write aqueous, not an acid, unless it's dissolved in water. Aqueous. H2S is a gas. It's just hydrogen sulfide. And you might have smelt it. It smells awful. It smells like rotten eggs. So make sure it's dissolved in water. That's what makes it an acid. Acetic acid, another very common acid. You've probably heard it by its more common name. This is vinegar. So ick, acetic, no hydro in front. I ate something icky, working backwards, change the ending from acidic to acetate, change the ick to an 8. Anything that ends in 8, we know is going to be in the back of our periodic table. We're looking for acetate. Here it is, number 2 in line, C2H3O2. Now you're going to see this one written a couple of different ways. I prefer just to keep the hydrogen on the front of it. A lot of people put the hydrogen on the end right here with the oxygen, or even write 2 oxygens and then an H. I like to just keep the H on the front. That way I always know what I'm looking for. H on front, we're working with an acid. Okay, a 1-to-1 ratio, that's pretty easy. A positive 1 and a -1 are going to cancel out. So then just rewrite that H, C2, H3O2, and again, make sure you make that aqueous, dissolved in water. And you see that one written a couple different ways. I prefer just to keep the H in front, keep it consistent with all of our other H's where the H is on front. We'll talk about what goes on the back later in the year, I think, if we get there. Finally, one last one. Phosphorus acid. Man, it looks a heck of a lot like phosphorus. Just that one letter difference. We got to catch that. It's OUS. So OUS becomes phosphite. So here's phosphite, PO3 negative 3. That's our anion. And hydrogen's always going to have a +1 charge. Hopefully we have that above hydrogen. Always has that +1 charge. So again, we do our crossing over. Bring the 3 down here, bring the 1 down there. It's going to take 3 of our +1 charges to cancel out our 1 -3 charges. So we'll rewrite that, kind of clean it up. We don't want those charges in our final answer. Phosphorus acid is H3PO3. Again, make sure it's aqueous. It's not an acid unless it's dissolved in water. All right, well, thanks for tuning in. We start a new unit tomorrow, so I hope to see you there. Best of luck.